This video is going to go through the solutions for the second worksheet from section 2.5. In this first problem, there's a lot of words in it, but basically it's asking you to calculate the molarity of a solution that was prepared from 0.8214 grams of potassium permanganate that were dissolved in a certain amount of water and then diluted twice. And so we're going to have to calculate the molarity and then do a couple dilution calculations on top of that. So our first step is simply to calculate the molarity of the solution initially. We have our 0.8214 grams of potassium permanganate, and we're going to calculate the moles of that using the molecular weight of potassium permanganate. And then once we get the number of moles, we're going to use the initial volume, which was 500 milliliters or 0.5 liters, to get the initial molarity. Of that solution, 2 milliliters were diluted to 1,000 milliliters. So we're going to do a dilution calculation. M1V1 equals M2V2. We're solving for M2. M1 is that molarity that we just calculated, and V1 is the 2 liters that they said we're starting with, and V2 is the 1 liter final volume, which gives us this new molarity. That solution is diluted again. We're taking 10 mils of this solution and diluting it to 250. And so we're going to do another one, M2 equal to M1V1 over V2. And there's that molarity that we just calculated. We're taking 10 milliliters of it and diluting it to 250. And here's our new molarity. And I've chosen to not write it in scientific notation to kind of give you the magnitude of the dilution. It's very, very low concentration solution. In the next problem, it asks you to actually calculate the mass of potassium permanganate that you would need to prepare this final solution, just sort of to illustrate to you why we would make the solution by dilution instead of weighing it all out. And so we're going to take this molarity that we calculated, and remember that we made 250 milliliters of that solution. So we're going to figure out how many moles of potassium permanganate were in that 250 milliliters, and it's a very small number. And now we're going to take that number and figure out how many grams of potassium permanganate were in that solution using its molecular weight. And again, I'm choosing to write it not in scientific notation, so you can see how small that number is. Our balances wouldn't even be capable of measuring that mass out. In the last problem, we have information about an antibiotic that puts sodium ions into a cell at a rate of 5 times 10 to the 7th ions per second, not moles, and we want to know how long it would take to increase the concentration of a cell by 8 times 10 to the 3rd molar sodium ions. And so this problem is kind of tricky. We know that we want to increase the concentration by 8 times 10 to the 3rd moles per liter. The volume of the cell is 2 times 10 to the minus 10 milliliters. I've chosen to express this in units of milliliter instead of liter, just to make it easier with this particular volume that we're given. And so this tells us that in order to increase the concentration by this amount, we need to put in 1.6 times 10 to the minus 15 moles of sodium ions. They're going in at a rate of 5 times 10 to the 7th ions per second. So I'm going to take this number and I'm going to multiply it by the rate. 1 second for every 5 times 10 to the 7th sodium ions. These units don't cancel out. This is moles and this is just straight up ions. So I need to use Avogadro's number in here to come up with the relationship between the moles of sodium and the ions of sodium. But the way I've set this up, moles of sodium cancel, ions of sodium cancel, and we do the math, it takes 19 seconds.